easier, make the build engineer's life easier. So really worth considering. In smaller circumstances, when you may have 2 or 3 builds and things are kind of small, you don't usually need to reach for mechanisms to enforce control or standardization. You can live in a kind of haphazard world. Now, when we talk about administration and standardization, we also need to recognize the fact that automation is fundamentally personal. Really, only the simplest of software can be built in nearly identical ways. We have to recognize the fact that software is complex, is fitting into different domains, has different technology needs, and treat this, as I said, as a first-class citizen. So a few years ago, there was somewhat of a revolutionary idea in the build space and in certain software stacks in general, the idea of convention over configuration, that we don't need to be explicit about every single parameter or configuration in an application or a build, whatever it may be. If we just agree on some defaults and some conventions, then we can get on with useful work and do that. So it was great in that it let us stop reinventing the wheel, but this can be taken to extremes where conventions become like chains. So our desire for consistency can prevent innovation because the tool simply doesn't allow other ideas for conventions or breaking out of those conventions. So conventions are good to a point, and the more flexible, the more we can push them, the better, but all conventions will break down at some point. You need to have ways to get around that. And this is becoming particularly more important as continuous delivery starts to kind of become mainstream and become a real differentiator between projects for all kinds of projects, for all kinds of organizations. So not just the LinkedIns of the world and the Netflixes. As everybody starts to move into this space, you need to automate everything. And you can't have a tool that stands in your way of this. And the idea that the tool doesn't have a convention for this out of the box or the convention doesn't work is not an excuse for not automating. So we need to kind of marry these two conventions up. Now a little bit more about conventions. So I spoke a bit about conventions, why they're good, and the benefits we get from them, but it's important to think about whose conventions. So the conventions that Gradle can give you, or that certain general plugins can give you, might not match your conventions. So conventions aren't a global thing. The way that the Java plugin structures a project isn't the iron law on the way to build Java projects. It's a conventional framework. If we work inside that, then we can get a lot of functionality for free. But there's nothing to say that that's the only way that things can be done. So whose conventions are we talking about? Well, ultimately, we should be talking about your conventions. What are the conventions for the way you build software? And these are first-class citizens, not just the conventions of the build tool out of the box, but your conventions, the way you do software at your particular workplace. That's a first-class concept. So you might want to extend the conventions that Gradle provides. Hopefully you can build on what's there. You don't have to do everything yourself, but you can extend on the conventions that come out of the box. You can make a statement that all projects that we build must use checkstyle for static analysis. That's something that's a convention that wouldn't make sense for Gradle to provide out of the box. It's far too bold a statement for every Java project in the world, but you can make that kind of statement about Java projects where you work, potentially. So in Gradle, we can extend conventions, we can build on them, or we can just replace them. In Gradle out of the box with the Java plugin, we get a concept of a main set of source. The Java plugin has this opinion about the way you should build software. We have a main set of source, and for a lot of people this works. It's kind of logical to think about, okay, I'm building a jar, there is the main source, which is the source of the jar. That's fine. That's why it's a good convention. But if this doesn't work for you, you need a way to replace it and build your own. And for some companies in a project, this doesn't actually make any sense. There is no concept of a main set of source. The picture is much more complex than that. So rather than trying to shoehorn the actual conventions that exist in their processes into this idea, they can actually build their own. And that's kind of what we're going to see. Feel free to interrupt, ask questions at any point. So we talk about Gradle being a toolkit. Like Ant, it's really a collection of tools put together. But unlike Ant, some of those tools are around standardization, reuse, and conventions. Ant is purely mechanical. Gives us the way to specify things to do. Doesn't really have anything for modeling conventions or patterns, these kinds of things. Whereas in Gradle we have plugins. If you're in my plugins talk this morning, we spoke quite a lot about that. We're speaking about it again in this session. Plugin stacks, the ability to compose plugins. It's this idea of conventions and reuse is so important that there is a composition model. Configuration rules, mechanisms for applying configuration to a bunch of different things based on some criteria or whatever we need to do. So this is a mechanism for implementing conventions. This is part of the Gradle toolkit. It's not just about moving files and compiling things. This is part of the model. And DSL extensions. You can customize the Gradle DSL to express your conventions and concepts, etc. And even just to provide shortcuts for common configuration. You can wrap configuration for the Java plugin, etc. And finally, we'll see init scripts, which are kind of a bootstrapping mechanism to give your customizations to Gradle a kind of global reach. So that all builds in your enterprise have a certain characteristic that goes beyond what Gradle has. So some of the more concrete things we're going to go through. We'll have a look at different aspects of the Gradle API. Gradle gives you access to a lot of the model and gives you points to customize, listen, configure, tweak, etc. This allows you to change the way Gradle works in slight ways without having to reinvent a whole mechanism. Configuration rules, this is a large part of this. Being able to very concisely and very effectively configure something in a way that has a broad reach. Plugins, packaging mechanism for bundling this kind of stuff up and reusing it across projects. Init scripts that I spoke about, and then using init scripts to create a custom Gradle distribution and using that in your enterprise. So the deep API, what are we talking about here? Well, in Gradle you program against an object model. It's not an XML interface, it's not a kind of static interface, it's just like using an application API. So there are many aspects to it. There are many objects, those objects have many methods, so there really are many, many levels to things. Now, if you're used to just been writing builds with a Java plugin, etc., you're shielded from most of this. You don't touch most levels of the Gradle API. And that's by design. If you're using the Java plugin, you're working in that framework, you don't need to know these details. But they are there to be used. The mechanisms that the Java plugin uses internally are there for you to use in other plugins. So the API is intentionally broad, intentionally has lots of access points, and just because you find yourself digging through the API doc doesn't mean you've gone wrong. It's perfectly valid to go looking at all those details and using the different entry points and methods and listeners, etc. The system is designed to work like that. So for an example, how could I use the API to enforce that nobody's allowed to compile against Hibernate? So I'm not adding Hibernate as a dependency. I want to somehow specify to Gradle that don't let anybody compile against Hibernate. This one? So I'm going to be doing most of this in a build script, when we talk about this stuff, we probably want this out in a plugin. But we get to plugins, I'll just talk about that a bit more then. So in this case, what are we doing? Everything looks pretty regular if you've used the Gradle build before, up until about here. And this looks a little bit different. Typically inside the configurations block, what we do, if we have to at all, is create some configurations, which are containers for dependencies. Most straight up Java builds, you don't need to worry about this, the Java plugin creates it for you. But here we're doing something different. We're not creating it, we're not adding dependencies. We're saying that the compile configuration, it has an incoming property, which represents a kind of view of the action of resolving a configuration. By that I mean during the dependency resolution process, when things are coming in and I'm resolving my dependencies into files, this gives me a bunch of options and things to look at it from that point of view. Yes?
So this would iterate through the individual items as they are flagged as being required, not as they're being considered for being required.
Okay, so the incoming object gives us this incoming view, and it has a particular method, one of many, called after resolve. So this says, after this configuration has been fully resolved, we've worked out what all these dependencies are, considering transitive dependencies, etc., the entire graph, do this.
Okay. Can you give me something other than incoming so I can contrast what incoming is versus something else?
So incoming is just, so the configuration object has a method called getIncoming. Let's have a look at the API doc. So here's the Gradle DSL reference. I have in core types here configuration. That's what I'm dealing with. It's kind of the entry point into the dependency management mechanism. I look at the list of properties I see here is incoming. So it's just a property, and it should be somewhere here. Here. It's of type resolvable dependencies, which is just a more focused view on the resolution process.
I guess the word incoming is sort of throwing me, but that's okay.
It could be called XYZ, like it's just a property.
It's just a property.
Yeah, nothing magic.
It's basically the dependencies.
Not quite. It is, but it's a particular view on it as they're coming in. It's just a more focused object. So if you think about it, I can get access to the dependency files here, but it allows me to, for example, if you think about it this way, it's the place where I can attach listeners for the resolution process.
Because it includes transitive dependency.
Yeah.
So, and it's the specific versions that were resolved, not the
Correct.
specifiers.
Well,
before.
yes. If I'm in the before resolve hook, I can't ask for what was resolved, but because I'm in after resolve here, so I guess the first point is that this is API that you don't see when you're writing build scripts, right? Somewhere else, and access to the mechanisms that are there. But these are not internal mechanisms. This is part of the API. This is part of the way Gradle works. It's completely valid to use all this stuff and customize to your heart's content. So, using that, you do require a little bit of knowledge, but it's all here in the documentation. I have a look at configuration, read through all that. Might want to grab a coffee when you do that. So, that incoming object, after resolve, after all the dependencies have been resolved, let's go and loop through them, looking for anything that looks like Hibernate. So again, dependency resolution is a complex process. There are many parts to it. You're just going to have to work your way through this API. And it is something we are actually simplifying over time. But we say, okay, for the compile configuration, the resolved configuration, which is our absolutely resolved view, which we couldn't ask questions about before we resolved, which is why we're in an after resolve hook, because this is going to happen sometime in the future. Look through for anything that has that group org.hibernate. If we see it, then throw an exception. There's anything that has group org.hibernate. Now, I don't have anything against Hibernate. I'm just using it as an example. Not saying you should put this in all your applications. Use Hibernate, fine.
What's the value of it inside of that closure?
This one?
No, the one above.
This one?
Yeah.
I guess it would be incoming. Resolve configuration. No, wrong one. Where was I? Incoming, resolvable dependencies. After resolve, I can tell because there's an action overload that takes a resolvable dependencies, and that one doesn't quite say it should. It's going to be an instance of resolvable dependencies, so it is the incoming object.
Okay.
Yeah. I mean, there's no real golden rule on this. You would always have to look at the API and see exactly what it is, because it might change from method to method. So now, okay, so I have this in place, and I run Gradle dependencies just to trigger a resolve. No problems. But I don't have commons laying in place. Now let's go bring in Hibernate. So it did do the resolution, it downloaded it, and had a look at the result and said, oh, no good.
Okay.
Couldn't you do it before resolution saying, we're trying to resolve, don't include Hibernate?
I could, but then this wouldn't work. Because this is an easy case, right? Somebody has explicitly said they want Hibernate. So I could just look through the list of dependencies and say, okay, Hibernate's there, no good. What if it sneaks into our application? Somebody says, I'm going to use Juice repository. They've got no idea that that depends on Hibernate. With this mechanism,
I see, for the transitive ones,
yeah. So before, if it's stopping it being a first class dependency is pretty straightforward. I could just stop somebody adding this line. Say when someone tries to add a new dependency, throw it that way. But I don't want it to come in at all. Yeah.
So, without wanting to derail too much and without implying at all that this is a good idea, let's say you wanted to...
I'm intrigued.
Let's say you wanted to prevent using Hibernate, but maybe there are multiple versions of Juice repository and only some of them use Hibernate, like maybe it's a recently added dependency. Is there a way to hook into the resolution to say, like, blacklist this version but keep looking instead of throwing an exception? Would you have to, like, write your own resolver for that, maybe?
You could do that. I don't have an example of it in this talk. You would take on a slightly different mechanism there. So in this case, we're using this to basically put in a kind of control mechanism.
Mm-hmm.
I don't want this to happen, it's no good. There's another hook. There are many hooks in the resolution process. One of them allows me to actually mutate the resolution as it's happening. I can see that somebody's trying to bring in version XYZ of repository. I don't want that, I want this. There are other ways to do version management as well, but there is a very low level hook as well. If we have time, I'll pull out an example of that.
Cool, thanks.
Yeah. But in that particular case, if some versions of Juice repository have Hibernate and others don't, with this mechanism in place, if that particular version doesn't drag in Hibernate, then everything's fine. Right? It won't throw an exception. So, what I've done is said that nobody can compile against Hibernate. I haven't actually said anything about using Hibernate at runtime. Another example. How do I, if you were in Jens's talk, talking about how for them, they integrate with lots of different build systems and they require a consistent interface from builds. That your build has to support I think it was a test task, a release task, a build task, etc. So what if you say that, okay, everybody's free to develop their own kind of Gradle build, but they must have a task called test, because it's a requirement that anybody can check out any of our projects and run Gradle tests to run the tests. So they must have a test task. So you're trying to enforce some kind of consistent structure in terms of the interface between the build user and the build. So we can just say, get a hold of the Gradle object, which represents the Gradle runtime, or that invocation of Gradle. And after project says that after Gradle can finish configuring each project, if it's a single project build, that's one project. If it's a multi-project build, this gets called for each project. If that project didn't create a task of type of name test, then throw an exception. So as I'm designing the build, etc., I can't do anything until I create a test task. Now, having this in one particular build doesn't make a lot of sense. We'll see how we can get this out and inject this into all of our builds. But in this case, that's where we have it. So I run, in my build, I just have a hello task. Actually, I do have a test task coming from here. So now I run Gradle hello. Everything's fine because I do have a test task. There it is. Now get rid of the Java plugin. And by the time the project was configured, there was no test task, and I get an error saying so. So I could enforce the particular standard of interface. There must be a build task, must be a release task, etc. And we can, in this example, we're using this to look for the existence of a certain task, but we have full access to the Gradle model here. I can look at any aspect of the build configuration. If I don't like it, throw an exception. Whatever that may be. Yeah.
If you explicitly add test task here,
No.
it will work.
Yeah, I meant to do that. Task, test. Yeah, fine. Yeah. So, I mean, this is, I'm not particularly asserting that whatever, that somebody has a certain implementation of test, that's probably going to be too much. Because any project, it might be a JavaScript project that has a different way of doing tests than a Java project, than a Ruby project, etc. What we're trying to say here is that you must conform to a certain interface so that everybody who checks out your build knows how to run it a certain way. And, I mean, just not to overstress the point, but you can do this about anything about the build configuration. Absolutely anything.
So you could say you must have these tasks and only these tasks as well.
Sure, yeah. Or you must have the Java plugin, because we can query for the list of plugins. Or you could say you must have this dependency, because we can look at the list of dependencies. This is what having a rich model with all the information there gives you. It's not just about configuring it for work, it's also about interrogating. So, this is very intentional, that the model is there to be used. As a user of Gradle, when you're just kind of, I just want to configure this build, so here's my dependencies, etc., and I use it in the build plugin, you don't see it. Because the plugins have pushed you away from this and abstracted it, so you don't need to know all that detail. But it's there to be used. So we think about it as a kind of onion skin API. You try and keep your build users at the top level. They don't need to know all that detail, and then you can kind of go through at each level into Gradle and get access to more and more low-level parts. And the best place to kind of see that is with configuration, because it's the entry into the dependency management mechanism, which is quite complex. So you'll see different levels of hooks, different levels of abstraction, then you get right down to the bottom, where you have really concrete concepts. And so, the outcome of this is that it's perfectly fine to read the Gradle Java doc. I get this sometimes that people are looking for how to do something, and as soon as they hit the DSL reference or they need to look something up, they think they've gone wrong. Right? So it's reading the Java doc doesn't mean that you've gone wrong. It's there to be read. So far, with that, if we think back to our Hibernate example, where we said no one's allowed to compile against Hibernate. Well, we implemented that in such a way where we had to have specific knowledge about the project. that there was such a thing as compile dependencies. And configuration rules allow us to apply configuration in a much more general fashion. We can configure future objects and objects that we don't even really know about. All sounds a bit crazy. So, one example. How do I configure all test tasks to be as parallel as they can be? Now, if I'm using the Java plugin, I get one test task. What about my integration test and functional test, etc.? There's nothing stopping somebody creating more and more test tasks for a project. And I want a general rule that says all those test tasks should run in parallel in a way where I don't require any knowledge about the project. So, this is my requirement as the build master, I need to make sure that tests by default do this. So here we have a Java project, it has some tests. A whole bunch of them. They don't do anything interesting, it's just to give us a lot. So standard kind of stuff, we need JUnit to write the test, and we have a built-in test task, courtesy of the Java plugin, pre-configures that for us. We're also creating our own explicit test task, other test. We now have 2 test tasks, and both of those need to run in parallel. So one attempt would be to say, okay, I know that Java projects have a test task, so in my plugin, so all the code down here is somewhere external to the build in a plugin, and I inject it in and say, okay, run the test task in parallel. If I run Gradle test, so let's run it serially first. Turn off parallelization. So that's how long it takes, not parallel. That's how long it takes in parallel. So we can kind of see the difference there. So if you're not familiar with Gradle test parallelization, it's pretty simple. For a given test task, we can just say how many parallel JVMs should Gradle use to run those tests. And what it will do is just break up the set of test classes and run them across all. We just have to turn it on and say how many should I use. And we're just interrogating the machine to find out how many cores we have, to specify how parallel we should go. Yeah?
By default, it's not
1. Yeah. Yeah, it's just a little too dangerous to do automatically, I think. Yeah. Especially if these tests happen to be hitting your database, and it can't handle more than 2 connections at a time. Well, get a new database engine would be the answer to that. So yeah, so the default is 1. All right, so
Could you do this for all the tasks of type test?
yes, absolutely. That's what I'm getting to. So in this point, Gradle clean test, we can see it's running in parallel here, but this other project has integration tests, functional tests, and we want them to run in parallel as well. We have other tests, which is actually running the same set of tests, so we can get the same at a time. But it's not in parallel, right? That configuration we did was just talking about that one test task. What we want to say is that I don't care how many test tasks you have, what their names are, just all the tasks that are test tasks run in parallel. And you can see the time difference. So other tests now run in parallel as well. Now that's kind of cool. That saves us some typing. But what about if we put it there? Now we're saying all tasks with type test have this configuration. There are no test tasks at this point. This is the very first thing in the build script. We haven't created a test task. We haven't created another test task, etc. I don't know anything about the test tasks. This is just what I want.
You haven't even defined test yet, have you?
No.
Because that's done in the plugin.
Yep. but I do need to move this forks guy up. Nothing magic there, it's just a variable I'm referencing. It was down below. So, at this point, when I run line 2, there are no test tasks. They don't exist. But I can still specify my configuration in that way, and it's still parallel.
So linear connection.
Yeah. So these configuration rules are very general and have a kind of reaching into the future kind of characteristic. This is really important. If your requirement is that all test tasks run in parallel, you can't know about all the test tasks in all the different projects. Right? So I can specify this very powerful rule here in one place and just have really global reach on that. So, how do I not allow Hibernate anywhere? Compile, test, runtime, integration test, compile, functional test, compile. I don't know. I don't know how it's going to be used. It's just not allowed to come in through the dependency management mechanism. Well, we did tasks.with type all, and tasks was a kind of special Gradle container, which we'll speak more about. But most things in the Gradle model are these types of containers. Almost all. So we could specify configuration rules about tasks. We can also specify configuration rules about configurations. There's a bit of a terminology conflict here. So when we say a configuration like this, we really mean a bucket of dependencies. When I say configuration rules, nothing to do with that kind of configuration. We had a configuration rule for tasks, then we have a configuration rule for configurations. So now we've said that, okay, our logic, and this is the same logic, instead of doing it directly on the compile configuration that we knew about, now just all configurations in the project have this. So I've got a dependency, a test runtime dependency on Google Juice. Bam. And notice in this case we've actually improved the error message. Instead of saying, oh, there's a Hibernate dependency, I give up, we've said, we found a Hibernate dependency in the test runtime configuration, this is what it was. So I'm not trying to punish somebody for using Hibernate, I'm trying to help them here and say, you need to get rid of this and give them some information to do it. And actually, since I wrote this demo, there's more API in Gradle where I could actually find the path to where this came from as well, so I could have an even better error message. I just haven't updated the demo. So see the difference? Instead of doing configurations.compile, we use this all method. And I believe that's where we're going. Yeah. Okay, so a bit more about this mechanism. It's all built around these two types that you'll see in the API. Domain object collection and named domain object collection. And there are various subclasses of these: domain object set, domain object list, etc. And the interesting thing about these guys, well, there's many interesting things actually. They are actually Java collections as well. You can pass these around to any Java API that's looking for java.util.collection, java.util.list, etc. They're kind of extensions of that. All right. And name domain object collection, as you can probably guess, has the same characteristics except that everything has a name. We can refer to those things by name. So in this case, we're going to create our own domain object collection. These guys are interfaces, and we're just using the concrete type here, and this is how it kind of works. You very rarely do this. You just use the containers that are part of the Gradle model. And if you were in my talk this morning, we saw that there is a method that you can use to create your own containers, project.container. So on the project object, there's a container method you can use to create your own here. So we have our container of numbers. We're starting it off with 1 and 2, over there on the right. And we're now saying that we're creating a new collection of just the even numbers. So all the numbers where it modulates 2 is 0, so it's even. And as soon as we do that, we can say, well, what's in even numbers? 2. Now we go and add a new number to numbers. See how it shows up in even numbers. We derived even numbers from numbers, but it wasn't a copy, it wasn't a snapshot of that point in time. It's a kind of reference, it's a kind of live structure. So all changes to the actual thing underneath propagate through effectively. So the key concept here is that this, even numbers, is effectively a specification. It means at all times the numbers that are in numbers that are even. Whenever I ask it for its contents, it effectively reevaluates that. And these guys are everywhere. We've already seen it with tasks. We did tasks.withType. Here we did a custom predicate. The task.withType you could think about as just being matching it instance of type. Same thing. So tasks, we can put configuration rules around the task, configuration rules around the plugins. If this project has the Java plugin, then do this check. Configurations, we saw this, configurations.all. Repositories, that's an interesting one, we'll have a look at. Source sets, for a particular configuration, the dependencies, the kind of list goes on and on. Everywhere you have a collection of something or a container, part of the Gradle model, it's one of these fancy collections. In my plugin talk this morning, we did something where we, for each thing that was created in a container, created a bunch of tasks, etc. Similar, it's the same mechanism, except in this particular talk, we're looking at this with a different perspective. We can use these configurations to have a look at and kind of verify the model, I guess. Instead of pre-creating things or doing configuration, we're using it to inspect things. But it's the same mechanism. There's really 3 interesting methods that we can talk about when, well, configuration rules. There is .all. So do this, whatever's in the closure, to all the things that exist in this container now and in the future. All the things. There's a more refined one for just when new things are added. So at some point, you decide things are all good here, just for new ones, or when things are removed. It's kind of used less often than you might think. Typically in Gradle, we build the model. We don't really undo things or change it in such a way. It can happen, so there are some cases for this, but we're kind of going through a process of building up the model. We're usually adding rather than removing. Okay, so at this point, I'm going to introduce plugins, and we're looking at plugins as a means for implementing this kind of control and generalizing it, especially across, right? So, and this is, plugins are just reusable build script code. There's no functionality that only plugins can perform, vice versa, build scripts. So, plugins can add new capabilities and tools, things like the Java plugin, etc. Give us new capabilities. Or, it may not be about adding new capabilities, or new convention, but maybe about adding new conventions or tightening existing conventions. Think back to one of the first slides I put up. I can say that all projects that we build use checkstyle. That's a plugin. Or if the Java plugin doesn't work for you, then you have to implement your own kind of framework, and you can use this as well. Now, I said this morning as well, but it's a good point to take home, that not to join these two guys together. One plugin should not do both of these. Keep a clear split between your plugins that add new capabilities and tools and ones that add conventions, especially type conventions. Because it should always be possible to use the capabilities and tools without the conventions for when the conventions break down or don't work. Not going to be talking about adding new capabilities, that's what we're really discussing this morning. We're kind of interested in the second bit. So, configuring the projects to do useful work by adding, configuring tools and capabilities. Sometimes it's about defaults. Every project uses check style. Other times it's about standards. No one's allowed to compile against Hibernate. So we're going to be working through, we've got some example conventions that we want to apply to all projects, and some of them are checks. And we're going to see the different ways in which we can apply this to all of our projects. So we're going to have use JUnit 4.10 for tests. All projects just have this, they don't need to configure it. All projects have integration tests that work a certain way. Dependencies are only allowed to come from one place. Nothing can get into the build unless it comes from our blessed corporate repository. And all compilation must be Java 1.5 compatible, no matter what kind of Java you're compiling, test code, functional test code, etc. Alright, so we know we need to use a plugin. What are our options for plugins? Plugins can be either scripts or objects, and script plugins are very simple. So here we have a Java project. So I'm a developer in my enterprise and I create this new Java project and we want to enforce our standards. So here's our script plugin. Here are our conventions and standards and things we want to enforce. So the first one, add a configuration rule to all repositories that if the repository is not a Maven repository, or it is a Maven repository but the URL is not our exact corporate repository, then in this case we're not going to throw an exception, we're just going to remove it and warn the user that hey, you can't use this. Sometimes we might want to throw an exception, doesn't matter. But in this case we just want to warn and say, no, sorry, no good. So we warn, then we just remove that guy from the list. And we also say that, well, since that's the only one, we may as well just go ahead and pre-add it.
So developers don't try to add it again later, it won't matter because it's already got it.
Yep. So we've now locked that down. Now, it only makes sense to try and add the JUnit dependency if this is a Java project. Our logic here is going to have global reach to all Gradle builds. It may not be a Java project, it may not have a test task, it may not have test compile, etc. We want to create our integration test source set, wire up the configurations here to say that our integration tests also include our test dependencies. That's what we're saying, integration test compile extends from test compile, so it's a superset of our test dependencies, create our integration test tasks, and some pre-wiring. So that by default, we use Java 1.5 around here, and no one's allowed to change that. Before we run any task that is going to compile Java code, check to make sure no one's changed this.
If you go back to that, if I set that source compatibility, that's just a variable, right?
Yep.
Could I make that final? It's Java, right? So.
Yeah, but this not really, because we're not in a constructor here, and it's not quite a local variable. This is a project property. The Java plugin makes this available at the top level, so it's not quite a local variable.
Yeah.
Alright, so is my Java project works fine, not a problem. But as soon as I bring in our corporate plugin, right, we've got some problems. Well, syntax error, it's the first one. Line 13. Oh, it's over here.
Double.
Got rid of that somehow. So, put in the corporate plugin. You tried to add this repository, but we removed it, only that one's allowed. So our rule kicked in. Now if we try and say Gradle dependencies, that's fine. However, if we try and actually compile something, then a do first kicks in and says, can't use 1.7, you have to use 1.5. So the way that we implemented that rule is just to check at the last possible moment, make sure that hasn't changed. So that's kind of only so good because we now would have to check this into our local repository. If we want to apply it to all projects, we could get it via HTTP. And this is just, the source for this is hosted in GitHub. That's just the GitHub link to that same file over HTTP. But this would be your Nexus or something like that, or your Artifactory. We get the same result. So we've gone from being build local to HTTP. We can use that across all our builds. And it has some other options. So that's as a script, and that kind of works, yeah, okay in this case, but we can't really unit test this code. We can't really version it, evolve it, etc.
Can't use it with -- offline, right?
Correct. Yeah. So now we're going to go through evolving this into a more thorough mechanism. So now what we've done is we've moved that same code out into a binary plugin. Right? So instead of being in corporate.gradle, we have a class here, corporate plugin.groovy. We're implementing our plugin in Groovy. It could be Java, doesn't matter. Class corporate plugin implements the plugin interface. This is kind of the buy-in mechanism. And the rest of this is pretty much the same. We have a few syntactic differences between the script and class environment, but the logic is the same. So we now have a binary plugin. We also have a unit test for this guy. We're using Spock here. The real details don't matter, but we're testing that when we apply the corporate plugin to a project, then we do pre-add the main repository. If somebody tries to add another repository, then it doesn't get added. So the point is here, we're unit testing our standards and conventions. I'm doing a testing talk tomorrow afternoon if you're testing build logic is the kind of thing that gets you excited. So now, I've put the logic in this special build src directory. The name is significant here. This is a kind of special place for Gradle. Lost my zoom. Anyway, you should be able to zoom in. So build src at the root of a project is special. Gradle treats that as an embedded build. In here we have our own build.gradle. This is what the build of our plugin looks like. We're using the local Groovy, and we're compiling against Spock to run our tests. Alright, so now let's have a look at our build.gradle. Apply the corporate plugin. Instead of doing apply from some file system thing or HTTP, say apply plugin corporate. And that works because Gradle has a lookup mechanism. If you ask for a plugin with a certain ID, it searches the class path, finds this file, there's detail in the user guide about how that works. But we can just basically provide a mapping mechanism to say that when we say apply plugin corporate, we mean that plugin. Right. So now I run Gradle test. It builds the plugin first, runs my unit tests. Okay, there's my warning about the repository. And I also get my breakage. So the functionality is the same, we've just changed the packaging mechanism. So that's kind of buys us something. We now get to write our plugin as a class, and we now get to have unit tests. It doesn't really give us a way to reuse that across different builds. So what we really want to do is to completely separate that plugin and upload that to our Nexus Router factory. So now we have the same code, it's the same corporate plugin, the same everything else. It's just a standalone project, just a standalone Gradle build, and we have some stuff in here to publish it. So we're going to upload it. You can use a file URL here instead of an HTTP URL, but the idea is the same. So publish this, we're done, we've tested it, it's all good to go. Upload it to our repository. Now, our consumer project, we've no longer got it on the class path automatically from the build source mechanism, we have to pull it in. So we say that we're pulling that plugin in, it's a file up there, but it could be HTTP. Gradle, and now we're in the project, not in the plugin. I say Gradle test, and there's my warning. Right. So in all of my projects, I can now reuse the corporate plugin across all the different projects. It's now reusable. It went up to Nexus or out of factory, and it's now versioned. It's just like any other jar. One of the things to consider is whether you want to add some conventions and configurable options. And you can use the extension mechanism to extend the Gradle build DSL. You have certain knobs and things that you want to allow everybody to tweak. You can inject into the DSL and make those knobs available. So what if instead of there being one repository, you had multiple corporate repositories? So just focus on this bit. Instead of having people remember all the URLs and do repositories, Maven, URL, etc., we can inject our own DSL for the user to specify which repositories to use. In this case, I want to use the libs repository. Don't know what the URL is, don't care. I want the libs. Behind the scenes, what's happened is that somewhere in the corporate plugin, we're creating a DSL extension of this type, and it gives us a use libs method. When that gets called, it adds that particular repository. Might be 5 or 6 different methods here for all the different kinds of repositories, etc. So this could be anything. I mean, you could extend the DSL to provide whatever kind of API DSL you want, using all the stuff that we've seen so far or anything else. The point is that if you look at this in isolation, this is all something that's in another plugin. This is the interface that your users have. And if you talk about standardization and administration, we can standardize because we actually provide less knobs to turn. They don't have to get the URL right, etc. We can just give them, these are the allowed ones, this is the DSL you can use to specify them, and we can even have rules to prevent them using anything else. Doesn't make sense for Gradle out of the box to provide corporate repos and libs. Doesn't know what that is. Doesn't make sense. But just because it doesn't make sense for Gradle doesn't mean it doesn't make sense in your workplace or enterprise. All right. Plugin stacks. Plugins can build on top of other plugins on top of other plugins. Now the reason I bring this up is that if you're going to go down this route of standardization, then you can quite quickly end up with lots of different bits of standardization, different things you want to do. It doesn't have to be implemented as one gigantic plugin. You can break that up over multiple and essentially tie them together if you like. We have an example here of the Java plugin, which when you use it might look like one plugin, but it's actually built on top of others. You have the base plugin, which provides very general build features such as clean, etc. A Java-based plugin which creates source sets and wires in a whole bunch of things specific to building Java projects, but doesn't make any assumptions about the way your project builds in terms of structure. And then the Java plugin that says there is a main and a test source set. I apply the Java plugin and just put some stuff in the file system and away I go. So getting more opinionated as we go down, but the idea here is that when I apply the Java plugin, I get those other things. Therefore, the Java plugin doesn't have to implement everything. We can stand on the shoulders of other plugins. And again, why? Well, one is to make it cleaner so we can have a, this isn't monolithic. But if these conventions don't make sense for you, instead of applying the Java plugin, you can apply the Java-based plugin and write your own conventions. You're just pre-configuring all that machinery a certain way. You might be able to stack on top of the Java plugin, but if not, if there's things that it does don't make sense for you, just drop a level lower. And if you're designing your plugins, you should keep this in mind. If you need to do this, kind of get underneath the Java plugin, there's not really any documentation in the user guide specifically on this, but if you use the Gradle forums or ask questions about this kind of thing, it's really not that difficult. So we can definitely help you with that. It is something we'll improve the documentation on over time, but it's something that's designed to work like this. All right. So far we've got our logic in a plugin, and we're having to opt in to using this plugin. I have to rely on all projects adding this, because Gradle out of the box doesn't come with the corporate plugin, doesn't know where your repository is, etc. But what I really want to say is that all builds, all projects have this functionality. This is where init scripts come into it. Init scripts facilitate cross-project configuration. They happen very early, they have a very global reach. In an init script, we work with a Gradle instance. We saw Gradle right at the start, we had Gradle.afterProject. In a build script, we work with a project. So our init scripts are working with the runtime. A build script is working with the project. And there are some default places where these guys are looked for. So, first one is a user-specific, well, the first two, the user-specific init scripts. On my box, I can have an init.gradle that is able to inject configuration or inject anything into all builds. Why might you want to do this?
For developers, might have certain things they want in all of their builds.
Yep.
Regardless of where the build script comes from.
Exactly. So the Java test task has extensive options on how it logs test information about when tests are executing. The names of the test, the full stack traces, all this kind of thing. As a developer, I like that a certain way. Other people on the team, not necessarily. I can configure the test tasks in there accordingly. Tasks with type test, test logging, etc. Benign stuff. It's not going to affect the way things build. It's just configuration on the machinery. Obviously not something you want to go nuts with here. You create non-portable builds if you start doing things in here that change the way the project builds. But it's for user level customization. If we're talking about global reach, the more interesting one is the Gradle home directory, which is the Gradle distribution, or where the Gradle install is. In there, there's a directory called init.d, And Gradle will look in there for any .gradle file and load it implicitly. So that means that any build running from that Gradle distribution gets that logic. That's the kind of thing we're looking for here. Also, you can specify it on an ad hoc basis with -i on the command line. A really good use for this is doing machine-specific or context-specific config. Most often the CI server. I've got certain restrictions or certain configurations or certain rules about the way things run in the CI environment, because that's my real build environment. More lax for developers, they can kind of experiment more and try different things. By the time they get it to the CI environment, they have to conform to the standards. So you can use whichever repository you like at development time, but it's not going to build on the CI server unless it's only building against the corporate repository. A bit more friendly there. What can init scripts do? Init scripts can load plugins, specify plugin repositories, environmental configuration, as we were just talking about, register listeners, etc., etc., etc. But conceptually, anything you can do in a build script, you can do it in an init script. Yeah.
On the previous slide, is there an order to which it looks in these?
This one first,
Yes. Good.
then this one, then everything in here alphabetically.
Thank you.
In the image script, do you have a handle to the project object? Because
Yeah.
projects haven't been created at that point.
You have to essentially register a callback. We'll see that.
Sorry, what was that question?
In the init script, can you get access to the project object? And it's a good point, because init scripts happen first, they're very global. There isn't any projects yet. Right? But we can register callbacks, just like after resolve. After you've done this, give me the thing and let me do something to it. So, here's our init script. And this ends up being what most init scripts look like. You don't want to implement your plugin in the init script. You generally are just preceding things. Right? So the Gradle object, which we're programming against here, has a method called allProjects. And that gets fired as projects sort of come online and get created. So as Gradle is looking around and working at the structure of the build and creating the project objects, before all the build.gradles are evaluated, this fires. So I can basically, at this point, the project is a blank slate, doesn't have anything, and I'm just injecting this build script config into all of them. So that, yeah.
I guess it's worth mentioning that you could put dynamic versions in there.
Yeah, sure.
And what is the caching policy on that?
Were you here for Daz's talk at all?
Is it the same? as-
Same, yeah.
Okay.
It's exactly the same machinery.
Does it use the same, default 24-hour?
Yes, yes, yeah. So 24 hours by default, this will be cached for. If I don't like that, if you were here for Daz's talk, you would have seen that you can configure that. I can say configurations dot, let's do it this way, class path dot resolve strategy, I think, cache dot dynamic versions for. There's a way of specifying how long to cache things for. And it's the same here. So the build script resolution mechanism is just the same machinery for application dependencies.
Could you set this to, set this to 10 minutes and the other default stays the same?
Yeah, they're isolated.
They're
Yeah,
separate.
yeah, absolutely.
Nice.
So now, word of warning about this. You push out a busted version of this, you've broken everybody's build.
Yep.
You will have lots of angry people.
Already know.
Yeah. So I didn't tell you to do this, so you're on your own. But it's a good point, and sometimes that's what you want. Sometimes you want a push model.
Yeah.
That I want to roll this out to everybody, just be careful. Okay, so that's my init script. Now, I need to publish this plugin. So this looks the same as before. It's the same code, separate plugin project. I just need to publish this quickly.
You just type UI.
Oh yeah, in Gradle you can use a abbreviated task name syntax. So the actual task name was called upload archives.
Oh.
And Gradle supports abbreviations and it's sensitive to capitals. So it went through a matching process and found that actually this the only thing this person could be talking about was upload archives. I'm lazy.
What does it do if there's multiple matches?
Tell you this is ambiguous, could have matched any of these.
Is archives a special name of the configuration?
Yeah.
It's hidden in the Java plugin, I guess.
Yes. So this is a convention, the Java plugin, which we're getting through the Groovy plugin, sets up the Java we produce to be part of the archives configuration. More on that. Daz's talk tomorrow is all about the gory details of publishing. Yes, so we just published it. Now, here's our repository, here's our consumer. Right, so here's our project. Now, if I try and run this, let's just say Gradle tests, I don't know what the corporate plugin is. Because this is all we had. Right? I'm using vanilla Gradle. Says, what the hell are you talking about with this corporate plugin? But if I run this run it the init script, which is up here at init.gradle, no problem. So we're kind of getting there, but I mean you don't want to have everybody run with dash capital I. So now we need to talk about the wrapper. So what is the Gradle wrapper? Well, it's really a way for Gradle to bootstrap itself. It's kind of weird. So even if you're using the wrapper already, you might might be something new in here for you. So previously, with Gradle 1.6, this is how I would wrapperize a project. And going through this process, we'll see what the wrapper is. So the build master, or the person creating this project for the first time, goes through this process. Wrapper, Gradle version 1.6. Right? Add this to their build. They have Gradle installed on their machine. They come out and run this task. Now what's happened is Gradle has generated a bunch of things. We get a Gradle W shell script and a Gradle W batch script. These things both do the same thing. They effectively set up the environment to run Java and then launch this guy, the Gradle wrapper Java. This guy is what, 50K? So it's not going to blow out your version control mechanism. And you check this stuff in. This now goes into version control. After doing this, let me just do something quickly. This is not part of the proper demo. I always forget to do this beforehand. 1.6. Nope. Okay, so I've never heard of Gradle at all. I check out this project. I want to build this project. I get it out of Git or SVN, I check it out, and the instructions say, if I want to build something, this is what I run. These scripts that were created, that's how I launch the build. So now I run Gradle tasks. What's the story with this project? The wrapper goes and downloads Gradle and pre-provisions it on this machine. So it downloaded the specific version of Gradle that we specified from the location that we specified, we'll come back to that, installed it, ran the build with that. I didn't need to pre-install Gradle to run the build. So I created a few things. One of the things was this properties file, and this specifies where to put the wrapper and essentially where to get it from. by default, it gets it from our servers. Question?
Oh, I was just thinking that this is what sold me on Gradle. This
Alright.
is the only open source build system I'm aware of that properly bootstraps itself in a version controlled way.
Yeah, that's a good point. Version controlled. So that means that I ran this project with the exact version of Gradle that the author designed it for. I don't have a weird problem because I have a really old Gradle installed, get weird behavioral issues. It's just pinned to the version. If I had already had Gradle installed, it doesn't download it again, just uses that existing install.
So, from that point forward, they have to run it with Gradle W.
Yes.
Right.
Yes. And you'll find that most of the time you're doing Gradle demos, we use the Gradle command. On all Gradle projects, I use Gradle W. Every single Gradle project I work on has the wrapper, and that's how I launch every single build.
Now, what about adding your corporate wrapper and all that other, your corporate plugin and all of that? Where would you do that in there?
We're going there.
Ah,
Okay, so that's the general wrapper mechanism. If you'd like more information on that, there is a wrapper screencast. It's about 5 or 6 minutes. Goes through that process in detail, explains it a little bit more. Maybe if it's not for you, your colleagues, tell them how cool the wrapper is. It's up on gradleware.com. Okay, so screencast. The wrapper doesn't have to come from Gradle servers. It can come from yours. The default is it gets the public vanilla Gradle. That doesn't have to be the case. Now, remember that one of the places the init scripts are looked for is inside the Gradle distribution. So we can customize the Gradle distribution within an init script and have the wrapper grab that customized Gradle. So that way, every build, because you use the wrapper in your enterprise, has these init scripts implicitly. Now this does mean you take on a few responsibilities, but we're automation people, we can deal with this. What I have here is a Gradle build that will download Gradle, unpack it, repack it including our custom init scripts, and upload it to our corporate repository. Right? Because I need to get Gradle, unpack it, inject our init scripts, and put it up there and out to our servers. So, I mean, I'm just using a copy task here for the upload, but I could use upload archives. It's the same process.
So, assuming that somebody's using our Gradle wrapper and they're doing their builds and we come up with a really cool innovation that we want to include, we would run this sort of a script,
Yep.
package it up, put it up there. The next time they run a build, the wrapper's going to check. It's going to say, oh, there's a change.
No, the wrapper doesn't, you can't push the wrapper like that. It's pinned to a version because it's a little bit dangerous to do that.
So they'd have to go to source control, check out the newest wrapper that would have the...
Yeah. So if you want to update the wrapper for a project, you have to effectively go and update that properties file that we saw.
Yeah.
So you go to SVN and do that. Now, you have to do that less often than you'd think because remember what our init script looked like.
Oh, right.
The init script only was just preloading that one particular plugin. And we have some options. We could use a dynamic version number, etc. We could actually go and hit a web service and look to see what is the latest version of this plugin I should use.
So for our corporate plugin, we would just upload the current version of our corporate plugin. It would automatically load that.
Yep.
So that would work.
That's why you want the most of the logic there.
Does that tiny 50 kilobyte wrapper jar still use the same code path as all the caching stuff? Like, does it put it in the Gradle cache? Does it know if it needs? You said like it'll only download the Gradle version if it needs to. Does it do that by putting it in the cache, or does it put it somewhere else?
No, it puts it somewhere else. It puts it in Gradle user home, wrapper, version number, etc. Okay, so here's my. I ran this before because I wasn't kind of sure what network I'd have here. This task downloaded Gradle from the public Gradle servers here. I can see it. Here's my Gradle 1.6. So we have custom Gradle distribution. Create a new zip, we need to download Gradle first. The zip content is everything inside the Gradle zip. We're setting a custom name for the zip, and also into the init.d directory put our init script, which is this guy. Alright, so automate the building of this thing. Gradle upload custom Gradle distribution. Repackage. Upload. Done. So you would need to do this every time a new version of Gradle comes out, which is every 6 weeks. So it's worth automating. Okay, so now we've done that. Now in my plugin, I need to publish this as well. Nothing has changed here. It's the same plugin code. In my project, when I wrapperize it, instead of specifying a Gradle version, I specify what's the URL to the wrapper. This one looks funny because it's relative on the file system. It'd look much simpler if it was a HTTP thing.
Does it have to be HTTP, or could it be like path to repository?
That could be it has to be a URL. It could be a file URL or a HTTP URL. What else were you thinking?
Well, I mean, then I have my repository, but it's 50K, so it kind
Like
of
Maven or
like a Maven. Could I zip it up and put it on?
This could link into a Maven repository. Everything in a Maven,
HTTP,
yeah, everything in a Maven repository is available via a URL. Yes.
Can I use flatdir instead URL?
Can you use what? Sorry.
Flatdir directory, local directory.
Yeah, absolutely. That's actually what we're doing here. This is on the local file system.
But it should be distribution URL or flatdir.
Distribution URL. Yeah, it's just a path to somewhere, whether it be a file URL or HTTP URL. But if you're going to, if you're going to put on the file system, it has to be everybody's file system, because everyone who builds this has to access this thing, right? So HTTP kind of makes more sense. All right, so now I need to wrapperize this project. This happens once. I'm in the wrong place. Okay. It's telling me it doesn't know what this is. We haven't wrapperized it yet. I was trying to build with my vanilla Gradle, which doesn't know about the corporate plugin, right? So just comment that out for now. Gradle wrapper. Now, inside our wrapper.properties, the distribution URL is whatever custom URL we specified, our Artifactory instance. So now let me put that back in. Let me run Gradle test. No good, right? I ran with Gradle. It's my vanilla Gradle install on my machine. Run with Gradle W. I get the path wrong? Oh, I did. It's 1.6. I have 1.0 here. So I told it a bad URL to go and get the wrapper from. Just haven't updated this guy. Okay, so now I want to run, need to comment this out. Regenerate the wrapper. Or I could have actually just gone here and edited this by hand. Right, changed, because previously this was pointing at this, which doesn't exist. I could have just come in here, fixed that up. Now let's put this guy back in. Right, vanilla Gradle. Boom. So, I got all that custom logic, used my customized version of Gradle, we injected that stuff into it. Yeah.
Is there plans to make the Gradle wrapper more subdirectory friendly for multi-projects, so I don't have to?
Yes, yeah. There is a, I'll point to a design spec at the end and it talks about that. Yeah. So one implication of using the wrapper is that previously in a multi-project build I could go into any directory and run Gradle. With this Gradle wrapper, those scripts are in a physical location. That does mean I can go into source and do this kind of thing, but that's not very convenient, right? So yes, we have plans to improve this.
So where does the wrapper install Gradle?
Gradle home.
Can the user control that? Or?
Yep, absolutely. So it's part of this guy, which gets checked in, and this is the file that the Gradle wrapper task generates. I could hand edit this, or I could configure that wrapper task specifically. There are a whole bunch of options on the wrapper task for that. So I can specify where the wrappers get installed to, yes. So I see we can combine those things together. Basically, Gradle's rich API, configuration rules, init scripts, wrappers, custom distribution to exert global control and domination. We do want to make this easier. We want to support something like this. Instead of you having to package up your own custom Gradle, as part of the init, the wrapper configuration, you can pull in specific init scripts. We're working towards it. It'll happen eventually. There's some complicated stuff in there. But yeah, so eventually you won't have to package your own Gradle. You can just kind of construct your own distribution based on a vanilla Gradle and some init scripts. At the moment, this doesn't work. Like, don't try this tomorrow. It doesn't work, doesn't exist, right? But just give an example of the kind of thing we're trying to do. So we want to make it easier to do exactly what we just did, pre-seed plugins for all builds. Different mechanisms for auto-applying plugins. We're starting to see this now. So you could make decisions about, you could have a plugin that looks at the physical structure of this project, what files are on the file system, etc. If I see a source main Java directory, this person has a Java project, pre-apply the Java plugin. These kinds of things. Pushable default behavior. So more control mechanism over pushing plugins out. Custom runtimes and the ability to test them. You can do this, and we do this when we kind of put this mechanism in place with different companies, set up a testing harness so I can run automated tests on my logic and my custom distributions. It just takes a bit of work. We want to make that kind of easy out of the box. And a global wrapper. So you install the Gradle wrapper script once on your machine, and it uses that configuration, which would essentially solve that problem. Basically what it means is that you have a command that looks around for wrapper metadata. Yeah. So you can basically install Gradle W in user local bin. That's what we're going for eventually.
Nice.
It comes with its own problems on how do you manage updates to that and etc. But generally it'll be a win, and we can hopefully solve those problems too. All right, any questions? Yeah.
What's the time horizon for those feature updates?
It's really hard for us to give those kind of answers because we just run from a prioritized queue.
Sure.
And roll out releases every 6 weeks.
Well, I mean, that answers enough in that it's like not in consideration.
It's definitely not in 1.7. I don't think you'll see much on this in 1.8. It's largely, in most part, driven by a particular customer of ours wanting things right now. When they yell at us, it tends to bump things up the priority list. But it is a pretty important aspect for us because Gradle positions itself as an enterprise build tool, and these kinds of things are really important. So this is not some kind of thing way down the bottom of the list. It's pretty high. There's a lot of work. There's work to do before we can get to these, and some of these things we're already doing. So in Gradle 1.7, we have the build setup stuff, which is we added a bunch of auto-apply plugin machinery to do that. So kind of picking at certain aspects. Until we get to this, realistically, I would expect to see it by the end of the year. That's about as specific as I would feel comfortable being. If you want to read more about our plans, you can have a look in our source repository. There is a directory called Design Docs where you can read about our plans for features. This is how we and the team communicate about our design and do things. So these aren't stale documents, these are living, breathing things changing all the time. And there is one in here called custom build runtimes, which talks about all the cases that we want to solve and all the issues and etc. So there's some interesting information in there if you're so inclined to look at it. There's also a bunch of other interesting specs in there too, there's quite a few. Alright, well thank you very much for coming. Hope you enjoy the rest of the conference.
I hear